All right, well, good morning, everybody. Thank you for joining Flex Train, a training opportunity brought to you by Johnstone Supply. So we talked a little bit about using duct calculators to design HVAC systems and to calculate airflow capacities through our ductwork. So now I want to kind of start jumping in for a couple weeks and talking about laying out ductwork and doing duct design with our calculator. And this week we're going to focus on standard calculations, and then next week we're going to focus on using a adjusted calculation based on your total effective length of your ductwork, so that we can calculate exactly the static pressure that we need to be able to keep within our parameters, because our goal is to stay around 0.5 inches of static on our blower. So our manufacturers design our equipment for about 1/2 of an inch of static pressure. And if you've looked at any of our previous classes on motors particularly, we discuss how different motors are affected by static pressure, especially above 0.5 inches. And they're either going to nosedive in CFM, or they're going to increase amps as they're trying to maintain CFMs. So there's consequences that we're going to gain after 0.5 inches. So when we are looking at ductwork, we're going to decide what static pressure we need to use to calculate our size of ductwork. This particular example, we're just going to stick to 0.1, just so we can get the understandings and we can see it easily on our duct calculator. So if anyone has a duct calculator with them, this would be a very, very good time today to look at what we're talking about on a duct calculator. Now, if we're looking at how to design our ductwork for our entire space, we're actually going to break it down per room. So if we had done a true manual J load calculation, it would give us a heat load for our structure. And we would have also gotten a design CFM, which is typically based on air conditioning. Or if we have a heat pump, it's going to be the same airflow for heating and for cooling typically. So if we take our total heat load for our structure, and so it's a known, and we take our total CFM that we're going to have for our structure, which is our known. The only thing we have left now is to decide how much airflow to put in each one of those spaces. So what we do is we look at our load calculation at how much of a heat load we have per each room. So we can take the heat load per room divided by the total heat load, and that's going to give us a fraction. It's going to give us a decimal point that we can then multiply times the total CFM, and that will tell us how much CFM we need for that specific room. Then we can determine how much duct to be able to get to that space. So we're going to look at just a basic ranch. We're going to look at a 2-bedroom, 1-bath, living room, dining room, kitchen ranch that has a heat load of about 80,000 BTUs. So if our load calculation says that we need 80,000 BTUs, well, now all we have to do is determine how much CFM we need to move into each one of these rooms. So all we're going to do is we're going to take our room load calculation divided by our total calculation. So this all these presentations comes from a heat load and duct design calculation class that we do, and it's typically a 2 to 3 hour class. So we're just kind of hitting the highlights of it. But essentially, that's all we're going to do. Room load divided by total load. It's going to give us a fraction, and we can take that fraction by the total CFM, and it'll give us our individual CFM. So if I had in my living room 25,000 BTUs that were required, 25,000 divided by 80,000, I get a 0.312. So I take 0.3125 times my total CFM, which is 1,250 CFM. So this would have been an 80,000 BTU furnace with a 3-ton AC. And I end up with 391 CFM for that room. So I'm just going to go through each room and take my room load divided by my total load, take that percentage times my total CFM, and that gives me my individual room CFM. So as we break it down, we now can see that we're going to have 391 CFM for our living room. Our dining room is going to have 234 CFM. Then we've got our additional rooms that we have to take care of, right? So we would do this as an exercise in class. I'd have everyone actually get their calculator and pull out the these BTU loads. So we take 15,000 divided by our 80,000 times our 0.1 or times 1250, which is our 1250 CFM. And what we would end up with is our CFM for those rooms as well. So our bedroom 1 would end up with 234 CFM. Bedroom 2 would be 188 CFM. Our bathroom would be 125, and our kitchen on this particular house only needs 78 CFM of airflow. Add them all up, we got 1,250 CFM, our total CFM for that 80,000 BTU load. So looking at that aspect, we can start laying out our ductwork because now we know how much CFM we need to get to each space. So if we start at our furnace, and we know that we need 1,250 CFM. Now I just need to know, okay, what size of plenum do I need right here? Because that's going to be one of our first things, right? We're going to set a plenum on this. So let's assume that this installation that we are calculating right now is going to be a counterflow. It's going to be a downflow installation on crawl space or basement. So we need to have us a plenum going through the floor to set our coil on, right? And then our furnace above that. So we've got 1,250 CFM. How big of a box do I need going through the floor? Well, if we do our ductwork based on 0.1 inches of static, then we can simply grab our duct calculator. We're going to set it at 0.1 inches, 0.10, and 1,250. So if we look across the top, I will have 0.1 at 1,250. And based on our class from last week, we talked about how we have all of our different dimensions that we can use, either in rectangular or in round for this. So if I look at it, I'm going to see that I have a variety of options. I could be a 10 by 20. I could be a 6 by 38. I could be an 8 by 26. Or I could be a 14 by 14. Sounds like a pretty common measurement, doesn't it? So my minimum size is a 14 by 14. A lot of common dimensions, if we had a C-width cabinet, would be a 20 by 20, which that's not a problem. That's oversizing. That's going to reduce our restriction on our duct. So we can always go larger with our ductwork. We just can never go smaller. So our minimum size for this would be a 14 by 14 going through the floor. Then we can start making our transitions into our different directions. Now, in our classes, I find that some people will prefer to design their ductwork from the plenum all the way out to the last register. And I have some that will start at the last register and work their way back to the plenum. And I'm okay with either one, as long as we end up with the same calculations. So for this one, I think we're going to go ahead and start at our plenum, and we're going to work our way out. So if we look at our plenum, let me get my Sharpie here. So we've decided that at our plenum, I can end up with a 14 by 14, because that will give me 1,250 CFM at 0.1 coming down through the floor. When I get down through the floor, now I'm going to have to branch off and start making my two separate runs. One that is going to take care of my bedroom 1, bedroom 2, and the other one that's going to take care of my bathroom, dining room, kitchen, living room. So if I simply look at the trunk that is supplying bedroom 1 and bedroom 2, I need to add those two up. So I've got 234 CFM going to bedroom 1, and I've got 188 CFM going to bedroom 2. I add that up, I now have 422 CFM total that is going to those two areas. This is where I can now start building my duct out. If I look at 422 CFM, so I'm going to take my duct calculator again. I'm going to set it to 422 CFM at 0.1, and I actually threw some slides in here so we can take a closer look at that. if I look at, let's see, 422, that would be this third one down here. If I look at 400, approximately 422 CFM at 0.1, that is going to give me my dimensions that I can run, okay? If I was working with round duct, I'm larger than a 10, so I would have had to use a 12, but we're working with rectangular for this particular installation. So most rectangular ductwork at our distributors is going to come in 8-inch width. That's the most common. We can get 10 or we can get custom if we want, but in stock, we're going to have plenty of 8-inch. So if I go an 8, I'm going to find that I'm landing right there, which is between a 10 and a 12, right? I don't have a 8x11 in stock, but what I do have in stock is an 8x12, the next larger duct. So 8x11 is what I actually needed. We don't carry 8x11, but we carry 8x12. So my first run off from my branch is going to be an 8x12. Let's back up now. So that gets us our first run at letter G. Letter G is going to end up being that 8x12. So I can run an 8x12 all the way down until I get past my first transition, so that I'm supplying my full airflow until I have gotten past my first transition. That means I have adequate supply of air for my 234 CFM going to bedroom 1. And by looking at this particular layout, I have 234 CFM going to 1 register. All right, so let's find out how large of ductwork I need for 234 CFM at a round duct. If I look at, I took some additionals here. If I look at 234 at approximately 0.1, looky there, that is just under an 8. So I'm going to be able to use an 8-inch round coming off from that 8x12. That 8-inch round is going to go over, and it's probably, judging by this, since it's a single drop into this room, that 8-inch round is probably going to end up being an 8-inch diffuser in the center of the room. It could be a variety of things. It could have been a rectangular. If it was a rectangular, I would have just simply had to look at that. So if I had 234 at 0.1, I could be an 8-inch round, or I could be a 4x14 or a 6x9, which would end up being a 6x10. So I have a variety of different dimensions that I can use for my register size. So this particular one, we'll just assume we're going to dump an 8-inch round into the middle of that room, just to keep this simple for today. So now we've got our first drop, and we've got our transition ready to roll to the next section of ductwork. So we supplied enough air. We took our 8x12 and we ran it past our first drop. We ran all the way to here. And now all that we need is to be able to move 188 CFM to bedroom 2. So if I look at 188 CFM at 0.1, if I'm running a 8-inch, because I'm running an 8-inch trunk, if I was running an 8, look there, I'm already down to an 8 by, that says 6. I could have branched that all the way down to an 8x8, because 8x8 would be the smallest transitional that I had in stock. So for the actual square rectangular duct, I'm going to run an 8x8 down to my last drop. I could also branch that down and run round if I wanted to, but typically when we're working with our plenum and with our actual transitional ductwork, we're going to keep it rectangular and then come off from it with boots to feed our individual units. So for this particular one, I would end up with an 8x8. So I would take that 8x8 and I would run it down to my final boot at bedroom 2. In bedroom 2, I ran an 8x8 down to it, and then I'm going to be dumping 188 CFM right here into bedroom 2. So if I look at 188 CFM on our calculator again, if I was looking at that from around, my 188 CFM at 0.1 would give me, it's just slightly over a 7-inch. So I can't use a 7-inch. Remember, I can go over, but I cannot go under. So I'm going to dump another 8-inch round into this room. And that's going to give me my airflow for that space. Ideally, it would have been a 7 1/4, but we don't make a 7 1/4 inch round. So we're going to be using an 8-inch into that room. So that room is now also going to be able to get an 8-inch round diffuser in the center of a room that was supplied by an 8x8 trunk to take care of that section. So that gets us all the way down the straightaway. So on that particular section, we're now going to have an 8x12 trunk that's going to supply an 8-inch register at bedroom 2. Just after that, I'm now going to do a transition down to an 8x8. So we're going to use a standard tapered transition right here. Then that 8x8 is going to take us down to the end of the room. We're going to blank it off, and we're going to come off the side of that with an 8-inch round into bedroom 2. So pretty simple layout, really, when we look at that. It's just a matter of understanding how much airflow I need for all my spaces. So let's start going the other direction. So let's look at this secondary trunk here. So with this secondary trunk, I have a living room that has 391 CFM, a kitchen that has 78, a dining room that has 234, there's that, and a bathroom that has 125 CFM. I add all those up, I have 828 CFM going this direction. So now all I have to do is plug that in. So I'm going to plug in my 828 CFM into my duct calculator at 0.1. That would be 828 at 0.1 is going to give me an 8x18, right? It's just under an 18. So we now have an 8x18 that is going to run our first section of trunk. So if we back up to that and we take a look at that first run, we have an 8x18. That 8x18 now is going to feed this entire first section. It's going to come past here, and it's going to go past our first drop. So I have an 8x18 running all the way to here. Now I can dump off 125 CFM off from that. So if I look at our calculator again, and I look for 125 CFM at 0.1, I'm going to find, oh, it's going to be my round one. So 120, there it is, 100, top right hand, 125 at 0.1. It's not a 6, it's over a 6. So it's hard to imagine that we were actually running a 7-inch round to this bathroom, but we will be, because we needed that much airflow. 125 at 0.1 is going to give us above a 6. That means we have to run a 7-inch round to this particular application. That's a big bathroom. If I need that much airflow in the bathroom, it's got a lot going on in there, but that's what it called for. So we can't assume that we know the sizes of ductwork. We can't say, hey, I got a bathroom and I got a 4-inch round going to it. I mean, that is pretty common. This particular bathroom is actually now going to need a 7-inch round going to it because it needs 125 CFM to it. So now we can dump 125 CFM off from that, which means I only need 703 CFM on this next section. So I got rid of 125 off from my 828, and that left me with 703. So now I can plug that number in. I can plug my 703 in at 0.1. 703 at 0.1 is going to allow me to run an 8 by, it's over 14, so it's actually going to have to be a 16, which means at that point I can drop down to an 8x16. See, the whole purpose of doing proper duct sizing is that we maintain the static pressure through our entire system, and we also minimize the amount of sheet metal that we do in our construction. You know, if I would have ran a solid plenum all the way down that 8x18, the whole length of this, that's a lot of additional sheet metal that I don't need. So I'm gonna be able to transition that 8x18 down to an 8x16 just as soon as I get past that first bathroom. And that gives me the opportunity to run that 8x16 down until after the dining room, because remember, I got to get my total airflow down to this point. So I run that 8x16 from there to there. And now I'm going to dump 234 CFM off in the dining room. So let's take 234 CFM, plug that into our duct calculator. And what do we got? 234 CFM at 0.1, there it is, bottom left, 8-inch round. So in this area, I can now run an 8-inch round. It's going to be sufficient for my airflow. And I'm going to put me an 8-inch round diffuser in the center of this room. So my living room or dining room just needs an 8-inch round. So that means my 8x16, when I got to here, is going to be sufficient airflow. Now I just need to make sure that I've got sufficient airflow moving down into my kitchen, right? So when I transition down, I got us to there, I got us to our next section. We just now need to make sure that we have enough ductwork for our kitchen and our living room. So if our kitchen and our living room, that is 391 CFM for the living room, 78 for the kitchen, that means I need 469 CFM. If I go to my charts again now, 469 CFM at a 0.1, that would be our bottom left. 461 at a 0.1 is going to give me an 8x8, just over 8x11, which means that's an 8x12. So I've been able to transition from an 8x18 to an 8x16 to now an 8x12 to run these last 3 dumps. So I move back here. I have an 8x12 feeding down to that area. And I'm going to dump off from that 78 CFM. So let's go back to our chart again. 78 CFM. 78 at 0.1 would be your bottom right. 78 at 0.1 is it's just over a 5, but it's going to be a 6 anyhow. So it's got to be a 6-inch round. So I'm going to be dumping that 6-inch round off into that space. So 6-inch running over into the kitchen. So now all I have left is what size trunk am I going to be feeding down here to the living room? Well, this living room comes over here and then it branches off, it wides off and splits. So that section C, I just need to make sure I got 391 CFM. So if I look at 391 CFM at a 0.1, yeah, there we go. Thank you. Top right hand. So 391, somewhere around there, 0.1, that's going to give me an 8 by, looky there, 8 by 10. So now I can go from an 8x12 down to an 8x10 and feed an 8x10 to the remaining 2 runs. And then I'm going to wide those off. I'm going to branch off at that point. So when I get to that point, then I need to be able to take off to my 2 additional side runs. And at this point, I can do one of 2 things. Looking at this, it's showing that I'm actually using a duct transition, which that means I'm going to continue using my 8-inch rectangular duct to feed down towards my drops, or I can do a round on this. So let's look at both of them. So that means that 8x12 runs to the end into the living room, and then I'm going to branch off and I'm going to do one of 2 things. I'm going to run square duct over, or I'm going to run round duct over, and we want to look at both of those. So I actually need 196 going to each one of those. So if I take my 196 at 0.1, that would be our top left one. I can do, if I'm doing rectangular or if I'm doing round, so there's 196 at 0.1, it's pretty close to there. You see my 2 options? I can run either an 8-inch round, or that says an 8x6, but we don't stock an 8x6, so I'm going to end up with an 8x8. So my final 2 drops are either going to be an 8-inch round, or I can run an 8x8 rectangular and then dump my my round out of it. So my actual register, my my round that I'm going to put in that is going to be an 8-inch round. So I can either go over with an 8x8 trunk and drop an 8-inch diffuser out of the bottom of it, or I can simply run an 8-inch round off from my 8x12 and dump my 2 living room registers. It's that simple. We complicate it very easily when we don't understand exactly what we're doing. But in a matter of 20 some minutes, we took a heat load calculation and we had an exact material layout for our entire duct system. If I was going to do this on my return, I just simply go backwards and I use the same calculations. I typically use 0.1 on my supply and 0.08 on my return. But as we talk next week, we're going to look at how if we want to keep that exactly 0.5, we have to know other factors. We have to know how much drop we have on our coil, how much drop we have on our filter, how much drop we have on a secondary heat exchanger, any of our IAQ products, all of our elbows. And that's when we factor in the total effective length. And then we can get a new friction rate based on that. But for most of my design, I use 0.1 on supply and 0.08 on return, and that gets my average sizing. So that was it. That's all it takes to build out a duct system when we know our heat load calculation. All right, well, that wraps us up for the day. I appreciate everyone's time, and we'll see you next week when we talk about duct design based on total effective length. Everybody have a great day.